Good morning everybody. In maths this week we're moving on from decimals to look at handling data, and today we're going to start by looking at some line graphs. So we're going to start by looking at a few examples from the challenges you have today, just to make sure that you know what you're doing. In the first challenge we have to read this line graph about the mass of Rocky the puppy, and there's various questions on that, but the important thing is that we can read the graph. So if I was to be asked what mass or weight was Rocky when he was 6 months old, I would go to my graph and I would look at the bottom axis, which tells me the age in months of Rocky. Now I've been asked what age he is at 6 months old, so I'm going to go along to 6 months and I'm going to read up my graph to where that mark is, and then I'll read across, and I can see that at 6 months old Rocky was 12 kilograms. It also works the other way around. So if I was asked how old was Rocky when he was 12 kilograms, I would start up here. My weight, the weight or mass of the puppy is up the side, and I would read across to where the line is, where the point is, and down, and I can see that when Rocky was 12 kilograms he was 6 months old. So whichever way around the question asks you, what you need to do is read up and across, or across and down, accurately using the lines that are already on your graph to get the most precise and accurate information. Once you have that information, you're able then to answer questions such as number 2, which says how much heavier was Rocky at 6 months than at 3 months. So you'll work out his weight and then do that sum. Question 3 says what was the approximate mass of Rocky at 9 months. Now this word approximate means roughly or roundabout. What's your best estimate of how heavy he was at 9 months? And the reason it says that is because if we look at 9 months and we read up, we can see that it doesn't come to an exact point on the graph. It isn't where two lines intersect. But if we read across, you can see that it's in between 14 and 16. So you can make a really good estimate there of how heavy he was at 9 months. And I'll leave the actual answer to you there. You can think about that one. Challenge 2 says the table shows David's mass to the nearest kilogram from the age of 1 to 17. It says you will need 1 centimetre squared paper, which you already have because you have your maths class workbook at home, and a ruler. Very important to use a ruler when you're ruling out graphs and information so that you're nice and accurate. It's not useful unless it's accurate. So the first instruction over here says using 1 centimetre squared paper in your maths class workbook, copy and complete the line graph to show the information in the table. Your graph should begin as shown. So as you can see, we've already got the information for when he was 1, 3 and 5. So that's already done in our graph. We're going to start here at 7, when he was 7. And it says when he was 7 he was 25 kilograms. 25 kilograms. Okay, so I'm going to mark on 7 years old. I'm going to look at 7, which is here. And I'm also going to mark up the side where it shows us his weight at 25 kilograms. So I know I'm looking along this line. So 7 and 25, and my mark is going to go there. I then use my ruler to continue my graph to that mark. Yours will be neater than mine because you're using a ruler. Now I have to do that for 9, 11, 13, 15 and 17. I've done when he was 7, so I've got to do the rest of those. Your example graph on your page here only goes up to 11, but of course in your book you'll continue it. So you might want to turn your book landscape so that you can fit that all in. You can see what will work before you begin. The second part is very important. It says give your graph a title. Now when we're doing a graph we always have labels for the axis. So we've got the age in years on the X or across axis, which is at the bottom, and the mass or weight in kilograms on the y-axis, which goes vertically up a side. So your horizontal axis is your x-axis, your vertical axis is the y-axis. We already have that information on our graph, but we also must give our graph a title. So it doesn't matter what your title is as long as it relates to what's on the graph. So I'm going to call mine simply David's weight. Okay, so it's up to you, as long as it relates to the information that's on the graph. Challenge 2, question 2 says, between which ages did David's mass increase most quickly? I've made up a little example for you on the graph of David's weight to help you understand how to answer a question like this. For the purposes of this graph, I have imagined that David's weight at 7 years old is 40 kilograms and that his weight at 9 years old is 45 kilograms. Those aren't the answers to challenge 2, question 1. It's just an example that I've made up to help you understand challenge 2, question 2. So again, the question asks, between which ages did David's mass increase most quickly? So what it's asking you to do is find out between which of these ages at the bottom his weight went up the most. So, for example, to find out how much his weight went up between 2 certain ages, if you look at age 1, he is 10 kilograms. Okay, so at age 1, he's 10 kilograms. And at age 3, if we read across, it's in between 10 and 20, so he was 15 kilograms. So you can see that the weight gained between the ages of 1 and 3, for example, is 5 kilograms. You will know between which 2 ages his weight went up the most by looking at your graph and looking at the steepest line between 2 points. That's the line that goes up most quickly in his weight in the shortest amount of time between which 2 ages. Now if you look at this one here, you can see the steepest line is here between the ages of 5 and 7. That means that the weight went up a lot in a short space of time. Okay, so if we look at age 5, he is 20 kilograms. And if we look at age 7, he is 40 kilograms. So we would do 40 take 20, and we know that the weight went up 20 kilograms during that time. So we can say that David's weight increased most quickly between the ages of 5 and 7. Now again, that's just a made up example. It's not the actual answer to your question. So when you've finished your own graph, you'll have to check it out, see where the steepest line is, and work out the weight difference between those 2 ages just to make sure that that is correct. The opposite would be true if you were looking at between which ages David's mass increased most slowly. So whereas with the weight increasing most quickly, you're looking for the steepest line. If you were looking for the weight increasing most slowly, you'd look for the gentlest line, the line with the most gentle rise or shallow rise between 2 points. Challenge 2, question 3 says, use your graph to find David's approximate mass at these ages. We're going to look at G, which is 4 years, because that's already done on your graph example for you. So what we have to do here, first of all, is find out where David is 4 years old. We are going up in odd numbers from 1. So 1, 3, 5, 7. But you can see on your graph that each year is marked by the horizontal lines on your graph. So when we're looking for age 4, it's going to be in between 3 and 5. So it's going to be here. So again, when we are reading the graph, we're going to read very carefully and accurately up from 4. And then we'll go across. And our line there stops between 15 and 20. Now remember the question said his approximate mass. So if our line is somewhere between 15 and 20, and as you can see it's about halfway between 15 and 20, that's what your answer will be. What's halfway between 15 and 20? And to work that out, we'll just do a little calculation. So 20, take away 15, it leaves us with 5. What's half of 5? Well, half of 4 is 2. We have 1 extra. Half of 1 is a half. So half of 5 is, which you probably know already, is 2.5 kilograms. If we add that on to the 15, it gives us 17.5 kilograms. So that would be a good estimate for the weight that David was at 4 years old. For question 4, what was the difference in David's mass between the ages of, for example, 5 and 10 years? Just simply work out what weight he was at 5 years, what weight he was at 10 years, and then find the difference. And again, it's just a case of reading up and across on your graph carefully and accurately. Question 5, you're looking for the weight gain. So how many more kilograms did David gain between the ages of 10 and 15 years than between the ages of 5 and 10 years? As an example of gain, I'm going to look at David's weight between 1 and 3 years old. At 1 year old, you can see that his weight is 10 kilograms. At 3 years old, you can see that his weight is 15 kilograms. So between the ages of 1 and 3, his weight gain was 5 kilograms. He got 5 kilograms heavier. Now what you'd have to do for question 5 is work out the weight gain between 10 and 15 years. But also the weight gain between 5 and 10 years, and then find the difference between those two amounts. Challenge 3. The graph shows David's height measured in centimetres from the age of 9 to 17. What did David's height measure at age 10 and 14? So again, that's just a case of reading across to his age. So age 10, reading up carefully and across carefully, and working out how many centimetres that is. Question 2 says, between which ages did he gain 7.5 centimetres in height? Now, you don't need to find out the gain between every set of ages to work this out. You can use a bit of common sense to help you here. I know that my height scale is going up in 5s, okay, so between 130 and 140 there are 10 centimetres, but this in between is 5 centimetres. So I know that it's going up. Each little horizontal line on your graph is 5 centimetres. So if I was looking at the weight gain between 10 and 11, it's very shallow. It's a very gentle rise. So it's not going to be anywhere near 7.5 centimetres, because for it to be 5 centimetres, it would have to go from one line up to another line. So I know I don't have to measure that one for this question. I have to look at rises which could possibly be 7.5 centimetres. Again, even if I look at 9 and 10, I know that that is 5 just by looking at it, because it goes up between two horizontal lines exactly. It goes up, it's one square high, it's only 5 centimetres. I'm looking for rises which are more than 5 centimetres, but less than 10. So you can narrow down the ones that you work out there to help you do that question a little bit more efficiently, a bit quicker. Question 3, about how old was he when he measured 165 centimetres? Well, this word about is very important. It indicates that your line isn't going to give you an exact answer, but you've got to make a good estimate as to how old he was when he measured 165 centimetres. So you'll find 165 centimetres on your y-axis, and you'll read across and then down, and you'll be able to have a good estimate of his approximate age. And question 4, use the information in the graph to write 2 different statements about David's height. Now there are many statements that you could make about David's height just from looking at that graph. You could do the difference in height between 9 and 17 altogether. You could do the ages between which his height increased the most or increased the least. There's lots of possibilities. You could talk about his height gain between 2 certain ages. It's totally up to you. There's loads of statements, and really what that question is asking you is, can you interpret the information in the graph? Can you now look at that graph, read it carefully, and know what it means? So you've just got to write 2 statements about his height, any 2 at all that you like.